Now that we've covered Java's foundational functional programming features, like lambda expressions, method references, and functional interfaces, as well as key methods in the JavaThread class, let's put all the pieces together in the context of the ThreadJoinTest case study. This case study shows how these Java functional programming features can be applied in a multi-threaded program. This program searches a list of phrases in the complete works of Shakespeare concurrently. It also demonstrates the use of JavaThread objects. We'll focus here on Java platform threads, but it's straightforward to modify this program to use virtual threads as well. We'll begin with an overview of the ThreadJoinTest case study program. This program uses Java functional programming features to create, start, and join thread objects that concurrently search for phrases in the complete works of William Shakespeare. As shown on this slide, we pass method references to various methods to create, start, and join these thread objects. This program is designed to be embarrassingly parallel. That means that there are no data dependencies between worker threads. A laundromat is an apt metaphor for embarrassingly parallel processing. In a laundromat, you'll have multiple washers and multiple dryers, and you can wash and dry your clothes in parallel without having to worry about any dependencies other than having to move the clothes from the washer to the dryer when you're done doing the wash. Therefore, scalability is only limited by the number of washers and dryers. As you can see from the output shown here, each work of Shakespeare is processed concurrently in its own Java thread object, thereby illustrating the embarrassingly parallel nature of this design. We'll now examine the structure and functionality of the ThreadJoinTest program. This project source code is organized into several files and packages. First, there's the ThreadJoinTest.java file, which is the main test driver program that concurrently searches for phrases in the complete works of William Shakespeare. There's also a utils package that contains general-purpose reusable classes. And finally, there's a resource package, which contains the complete works of Shakespeare and the list of barred phrases to search for. Bard is a nickname commonly applied to William Shakespeare, who is known as the Bard of Avon. The remainder of this lesson will focus largely on how the ThreadJoinTest program obtains its input data. The Bard Data Factory utility class applies Java functional programming features to read the contents of text files and return this content as lists of string objects. A Java utility class is defined as final and has only static methods, no non-static state, and a private constructor. One text file contains the complete works of Shakespeare, where each work begins with an @ sign, which will match with a Java regular expression, as shown momentarily. The other text file contains the barred phrases we want to search for. Each phrase appears on a separate line, as shown here. We'll now take a look at the implementations of the various methods in the Bard Data Factory utility class. We'll start by walking through the implementation of the process file method. This method factors out common code by using a function parameter to process the contents of a file associated with a file name. The file name identifies the file to process, and the function identifies how to process that file in some manner. As you can see, this method applies the Java function functional interface to factor out common code used by the getInput and getPhraseList methods. The first thing the process file method does is call the getResourcePathFile helper method to convert the file name into a path URI. This helper method gets a path to the designated file in the resources folder. Once the URI path has been obtained, the readAllBytes method on the files class is called to open the file and read its contents into a string. The process file method implementation now calls the fileProc function parameter to process the file contents and return a list of string objects. The removeIf method is then called on the strings list and is passed the string isEmpty predicate method reference to remove empty string objects from the list. Finally, the list of non-empty string objects is returned to the caller. We'll next walk through the implementation of the getInput method, which returns the contents associated with a file name as a list of non-empty string objects. The file name identifies the file in the resources folder containing the complete works of Shakespeare. The splitter parameter is bound to the @ character that separates each work of Shakespeare. We'll use the @ character as a regular expression to split the file into works shortly. The getInput method implementation leverages the process file helper method we looked at earlier. When process file is called, it's passed the file name as well as a function that splits the file associated with the file name by the splitter regular expression and returns a list containing the complete works of Shakespeare. The last method implementation in the Bard Data Factory that we'll walk through is the getPhraseList method, which returns phrases associated with a file name as a list of non-empty string objects. The filename parameter passed to this method identifies the file containing the barred phrases to search for. As with the getInput method implementation we just looked at, getPhraseList also calls the processFileHelper method. When this method is called, the file name is passed, along with a function that splits the file associated with file name by the new line regular expression and returns a list containing all the barred phrases to search for. The \\R string passed to split is a regular expression that matches any line separator on any platform. Now that we've walked through the implementations of the barred data factory methods, we'll show where they're applied in the ThreadJoinTest program. The ThreadJoinTest class defines several static fields that are initialized by these barred data factory methods. For example, the minputList field contains a list of the complete works of Shakespeare it obtains by calling the getInput method on the barred data factory. Likewise, the mPhrasesDefined field contains a list of barred phrases to search for, which it obtains by calling the barred data factory getPhraseList method. When the program is launched, it creates and runs an instance of ThreadJoinTest that uses these two lists to guide its concurrent processing. This wraps up the first part of our ThreadJoinTest case study, which demonstrates how to apply Java functional programming features in the context of a multi-threaded application.